Hey, welcome to my first video on, I think it's kind of like, it's technically geography. It's like chemistry and geography combined, because I have some very interesting objects, I'll say for now, that you might be able to guess from context and what I'll talk about in a sec. These objects I got from my holiday and they're very interesting. So you can see there is this kind of picture, this diagram which I've drawn constructed on my model. This is meant to be kind of like a cliffside, and then there's like sand, like a beach. So we have this top layer where we have trees and some bushes. This top side can range between a half a meter to about 3 meters in the width of about like it's like grass and top layer soil. And a bit under that there's a second layer which is like dirt, wood and clay. Dirt becomes wood when it's wet, but you kind of get what I'm saying, which can range from about half a meter to about 3.5 meters, so 7.2 meters, which is kind of like if you were on this beach you would kind of be able to see that as the layers go down. You see the dirt, the clayish sort of materials with also a little bits of some disconnected rocks in them. And then as you go further down you get to this main section which technically does have individual sections as well, but it's a bit more complicated, but we go on more of the chemistry side and less of the igneous rocks and all that. Well, we touch a little bit on that. So, as you might have seen, it's the blue and the red. The blue represents something called quartz streaks, where on the sides of the cliffs and just on rocks in general, you have like a white line that's like textured and a little bit shiny, and that is made of quartz, which is the same thing which is in sand technically, and basically those rocks, which is the chemical formula is silicon dioxide, and silicon is basically is in the same group as carbon, so it can form 4 bonds. Silicon dioxide is very versatile, it can have many forms, while carbon dioxide doesn't really, it's just, it can go in the soil and all that, but it doesn't really take many forms other than it doesn't do much interesting things. It kind of does for like the atmosphere, but nothing to do with like rocks and mineral science. So anyway, the blue represents streaks of quartz, compressed quartz, which you will see on the cliffside and further on. The red shows iron oxide and just iron deposits, because you may often see small areas with like reddish kind of like bleeding areas of stone, and that stone, that bits with iron deposits, can oxidize to form iron oxide or iron oxide, which is Fe2O3. So that means that's technically rust, which is weird, like natural rust, but not. It kind of technically is, and it does something very interesting with the quartz. It can form, because there's different types of quartz, which we'll get into a second. This is just diagram. Areas with iron oxides are covering the streaks of quartz, kind of mixed to form impurities in quartz. But this is one of those things where impurities in quartz can form amazing things and interesting geological events. We get red quartz, or you can kind of get amethyst, which is purple quartz, kind of from this, but not really. It's more from aluminum and gamma radiation from other rocks around it. But mainly in these sort of formations you'll find clear quartz, milky quartz, red quartz, and possibly some quartz. Actually no, I have some. I kind of spoiled it, but yeah. And normally from just viewing on the side, it would just look like a white streak. You wouldn't exactly see the red quartz there. You would just see like a white-ish streak, not like a clear streak in glass, or clear like hazy glass, just like kind of the colour of this white voidish, like a little bit more milky. just not really interesting. I mean, you could kind of have like tabletops, but me, that's boring. What's interesting is what's underneath. Because most of the time these cliffs stay stable and nothing really, not really does, or how. The reason why the world is shaped as it is because of cliffs collapsing, more sediment, which carries down like streams and rivers, deposits in other places and mixes and does loads of stuff. But normally it doesn't really do much, and you don't really see what's underneath. But I went to a beach in which there was a cliffside, and this beach was quite longish. There was really many other people in it. It's very, very warm, and at the end where there's a cliff that goes quite high up, it's collapsed some time ago recently, I think, because there wasn't really any signs saying you couldn't really do anything with it. Obviously, it's nothing like hitting like the walls with a hammer or something like that, because that's stupid. But yeah, it didn't really. The place doesn't really visit it too much, but it's a very nice area. I don't actually remember what it's called. And because the cliff had collapsed, and I could see nearby on the cliffs from afar as I came onto the beach, I could see on the far that there were some quartz streaks. And I think, that's interesting. That I got an opportunity to have a look what's beneath. And because this part basically collapsed, so the front had been ripped off, now you see the underside, you actually get to see what the valuable side of the quartz, because there's normally just like flat quartz which you see on the stones like white streaks, boring. But on the underside you can find clear quartz crystal clusters, which are like the little peaks that if you type it in. Like I actually have some, like they're not really that big peaks, but this I didn't buy from a shop. You can tell because it's quite dirty, because I'm actually going to clean them. I've got more, and I found this in the pile because there's quite a big pile of like rocks that I had to like kind of dig through. And there's this giant rock with that wasn't connected to anything, so it was safe. That I just had to pry this off, and it's quite nice. And it's not. It's like 99% like milky hazy quartz, so it's not really worth much, but it's not about exactly the value of money that you can get from it, but the value of knowledge you can get from it, because it's just very interesting. Like you can find these little things in nature. And quartz is known for having like a kind of hexagonal faces where you have it's kind of pointed, and then you have like hexagonal rhombi faces. And quartz can has many types within its colours, but also many types within its structure. You can have twinned quartz, where like two pieces joined at like a point. They're not joined as in like the very base, it's joined in like a midsection. I don't actually have I don't think I have any examples of it, I might. And then you can have a very unusual form, which, okay, I think I might look in my book because I wrote it down. Very unusual form. Yes, you can have an unusual form of quartz called... Where is it? Bruise quartz. I think bruise quartz, where it's kind of like if you have like one point, and then you have loads of like kind of quartz, smallish quartz, like peaks around it. And that's actually, the thing is my camera isn't that good, so you can't see it. On this rock, it is actually you can just see it from far away. It's quite shiny. This piece has that kind of like bruise formation where you have like kind of little pieces coming off. And yeah, so it collapses. Let's go down. And yeah, so it's like this, collapse, which, as you can kind of see, it catches a bit of that quartz streaks, so you would get some clear quartz and milky quartz behind it. Then you get the bits of quartz which are mixed with the iron oxides and iron deposits, and then you get smoky quartz, and you also get red quartz. Yes, red quartz also has another name, which I for some reason have forgotten again. It is annoying. Okay, where is hematoid? Yeah, there we go. Hematoid quartz, which comes from a word to describe the kind of iron deposits. So as the kind of piece falls down, the back bit is exposed, which forms like kind of clusters, which is like geodes, but geodes kind of it's not as uniform as the ones that you can kind of buy like geode breaking kits with like a geode. But I always find that I feel like those they kind of like or maybe they're kind of I don't know how you can fake it. I don't know how you can fake diamonds by science and a few other breweries, because of the birds and other gems. I mean, it makes sense to do it. But anyway, it's just like geodes. They were just they seem real, but they just feel boring. You know what I mean? Like you can buy them for relatively cheap, but for the amount of I don't know, it doesn't matter. Anyway, so it comes down, and the exposed bits are on the inside bits for many waving patterns of like gaps with different quartz deposits and all that. But normally, no one really ever pays attention or finds it, because as over time it like rains, gets weathered on, sediment forms over the exposed bits, and then the rock just becomes like a normal rock again, and then stuff piles, then more falls, and then eventually it becomes hidden again. But luckily, I found some, and there's actually probably more on the beach. We just have to dig around a lot. It's quite deep in the rocks. Yeah, it falls down. I keep losing my stuff, and it's just not fun. There it is. That's all. 2 billion year old water, probably older, or not. Yeah, you know, old water. If you know, you know. 2 billion year old. Okay, so we've got silicon dioxide forms 2 double bonds with the oxygen, but which is, if it was just like a kind of gaseous form, which is boring to me, when it's in a crystalline lattice form, so it's going to repeat it. Since the if you remember what I was talking about, so since silicon is in the same group as carbon, it forms 4 bonds. So these are 4 bonds filled. So how does it connect to the other silicon dioxide compound to form a kind of lattice crystal structure? Because it breaks the bonds to then form technically silicon tetroxide, kind of. That's not exact. That's not. This is the chemical formula which is being repeated to this, because silicon is negative by 4, and it's kind of unstable, so we don't like that. That's why it forms a crystal structure. I could try and draw the crystal structure, because crystal chemistry of structures does get complicated, but I will go over like a briefing of it. We have like looks different to this, but I'm pretty sure that's what I've seen, something like that, where you have it in like a cubed, and then you something like that. Okay, I've lost my rubber again. I need to keep it in one spot because I've lost it like so many times today because I recorded a video earlier. Where's... Okay. No, seriously, where is it? I lost my black pen earlier. I'm really bad with losing things. It was... What? Hold on, I'm gonna pause it. Found it. It's because when it's turned up, the kind of blackish texture is like the same colour as my carpet, so it's kind of hard to see. Anyway, we found it. So like this, and when you get different forms of quartz, so we have quartz spelled like this. It's Quartz. Quartz. You can have many variations. You have clear, little to no impurities whatsoever, milky, which means normally there's a lot of like structural damage, and also there's probably a lot of air pockets which scatter light to the where it's not really see-through anymore. You can also have like a mix between where it's kind of clear but it's kind of milky, which has kind of impurities. And then you've also got amethyst, which is purple, or can be like very light purple to very dark purple. The darker, the more amount of impurities, which means the more valuable. So if you have a really big crystal of dark purple amethyst, it's actually worth quite a lot. So if you somehow find that, that's worth keeping, I guess. Which can be formed by, I'm pretty sure, aluminum impurities, or you could just call it quartz, which is kind of boring, so amethyst is cool. Then remember we had red quartz, which you can simplify all of these to how I call them. So Q O C O Q O N Y Q O N Y. So this is amethyst, clear quartz, or standard. You can also remember red quartz, so it's like red, which is I just write it down again. What was it? Hematite, that's it. Which you would write as, or I would write as H. And this is formed by iron oxide impurities and aluminum, so alloy. And what happens, how the impurities work is within a structure, within a repeating lattice structure, some points, which they're called colour centers, that's why they have different colours, atoms or anions of like different metals and certain oxides go in between and replace like an oxygen, or go in the centre of like a collection of the silicon dioxide, knock some of the oxygens off, or replace one of the silicons, and it's only like one or two. So you can't really give a direct chemical formula, you can only say that's an impurity. So iron oxides remove like one or two silicons, you have like a small like rust point, and for all of those points connected, not exactly connected, but the colours they create like a nice reddish colour, looks kind of like rusty. If you have aluminum, you can create amethyst. But the thing is with aluminum, it's a little bit versatile. It can create, I think, 2 to 3 different types of quartz, which means it gets even more complicated and it goes to the way it's actually formed, which is at different heats and different pressures, and when there's other chemicals in there with different types of radiation. We've got gamma, we've got UV radiation, and a bunch of stuff. I will actually have I think I'm planning to do a video in some time about radiation, and then some time after that about decay, which is, I think actually I'll try and plan that to do in like after my channel's got a bit more, because that video will be very complicated. Because, well, I mean, half-lives and decay is kind of simple, but the equations do get quite complicated, and I will be trying to go in depth. So in a little bit in the future, I think maybe like 2 weeks or next week, I'll do about the types of radiation, and also some types of radiation which aren't as known, which don't really give them cool names like gamma or beta or alpha, and I will show you how I name them in terms of Greek symbols and also Russian symbols, because they're not really used. Anyway, so that's that. We also have pink quartz, which is kind of like rose quartz, which can be formed by impurities as well. And okay, there's also technically two types of quartzes in general. There's alpha quartz and beta quartz, or low quartz and high quartz. High quartz, so beta quartz, forms hexagonal kind of structures, while alpha quartz forms triagonal kind of crystals, so it's not as valuable, I'm pretty sure. And then you have some other types of quartz, which, let's say we have orange or citrine, can be formed, so citrine which can be formed by aluminum and phosphorus, which is interesting. Phosphorus, you don't exactly see that too much with like crystals and minerals too often, and it's very interesting because it's called citrine. If you might say, that kind of sounds like citron or something to do with that, because it kind of is. It's named after, because it's like an orangey colour, even though the colour is similar to, it can be similar to the red quartz. It's like quite far away with the relation, and it can There's also a word called chiral, which means it's not identical, and it's like mirror form in a way. It's a little bit complicated. Pretty sure Vsauce has done a video about it. You can go and have a look at it. To do with like about mirrors, or is it like a short? I'm not exactly sure. But I think that will kind of, I'm just going to wrap up today's video. Actually no, I'll just give it like a brief show. It's kind of not too much shown, because if you want to go in depth, it does get very complicated, and for a video like that I have to do a lot more planning. So this is another rock that I got. It does have, like, if you can see the twinkling, there's loads of like quartz crystals here. I can see that there's clear quartz. There is also, I'm pretty sure, yeah, there's red quartz. There is, I think, some smoky quartz too. There's a decent collection. As you can see, like, kind of like the red, you can't really see on the camera because my camera's bad, but there is like reddish colour. For some reason the camera I'm picking up, that is like rust colour, which is kind of what it calls. This is the underside. This is the side that you would kind of see on the beach. This is the side under, which you'd have to take from the rock. Don't ask me how long it took to do that, but I did it. It took the entire time I was at the beach. But this, you can kind of tell I did take this off another rock, because I like the way it's kind of broken off. So there's some like more quartz in there, which is clear. I will do the cleaning it tomorrow with acetic acid, also known as vinegar. Actually, I think I might show a video of it, like it'll be like a short form video, possibly. I should probably show like some pictures after. You can also kind of see, because I'm going to break some of these apart because they do have some inside. You can see kind of like the layers, because it's from like a layering system. Okay, on this one, this is a kicker. Oh, it's heavy. It has like a mouth. It's like a proper geode, which is just full of, you can't really see because my camera quality says it's not very good, but there's some like crystals that are like that about that long and like that thick, which doesn't seem exactly too impressive, but for this it's quite much, and it's just beautiful. It's just in this one there isn't that much clear or milky quartz, just loads and loads of just red quartz that goes quite deep through the stone, and I'm gonna break it through tomorrow. We also have this other stone which is mostly just rock and quartz streak, so it's not very much. It has a bunch of fine, tiny little pieces of showing up grey on my camera, but there's red and orange quartz, which is interesting. There's a small amount of citrine, very small amount of citrine, which is very interesting, and I will be cleaning out this tomorrow, watching some pictures. But yeah, this video, if you want to know more about quartz and chemical structures in more complex, deep form, there's actually some which goes not just like mineral science, but like proteins and engineering, that sort of thing. It's goes into some very complicated format, which I've actually done a little bit of work on. So let me know if you want to know about that in the future, and I will. So thank you, and remember, stay curious.